Well, ladies and gentlemen, welcome to the ASMBS Edward Mason lecture. Our lecture this year is going to be given by Dr. Ted Adams. This is a singular honor bestowed once a year, and it's in honor of our founding president and really the founder of our entire field of bariatric surgery, Dr. Ed Mason. We all had the opportunity last year to hear from him and to get his insight in really what's been a groundbreaking change in how we treat the obese patient. I want to mention that our original speaker was Dr. Pierre Marceau, but he suffered a health setback and wasn't able to make it. But I am so very honored, privileged to have Dr. Ted Adams speaking to you today on population-based impact of bariatric and metabolic surgery. For those of you that know Dr. Adams, you know that he is both a gentleman and a scholar. He's always on time, as you can see here, and he has also been absolutely instrumental in getting our message forward about the tremendous impact that bariatric surgery can have on the entire population. His work that was New England Journal of Medicine around the survival benefit is one that I quote in almost every single talk, and probably our best demonstration of what bariatric surgery can do. He holds 2 PhDs, both in exercise physiology as well as in public health. He's been a long mainstay in the public health of Utah and the country. Please join me in welcoming this year's Edward Mason lecturer, Dr. Ted Adams.
Thank you, Dr. Morton, and thank you, organizing committee. I appreciate this opportunity, and I extend my best wishes quick recovery to Dr. Marceau. The first and most important aspect of my talk is to give an announcement for Dr. Blackstone regarding tomorrow's opening of 007. Going to the dinner last evening, that's all she could talk about. I've chosen to cover 4 concepts that hopefully will be of interest to you, and the first relates to severe obesity and extreme thinness as family affairs. By way of background, I've had a lot of people since my involvement with research in bariatric surgery ask me, how is it you became involved with bariatric surgery? And to answer that, I began to share with them, hopefully not too boring of an overview of my past, that my real initial interest in medicine and research has been in the genetics of human obesity. And by way of background, there are 4 activities that I would like to briefly set the stage for today's lecture that relate to population health and obesity. 4 activities that I have been very involved with over the past 30-plus years that are related to the genetics of obesity. The first is the Utah Population Database. Some of you may or may not know of this impressive database that is in Utah. It contains large families, and that's one of the advantageous aspects of Utah. There are large families. Here's, for example, one family reunion picture. Detailed genealogical records, large founding population, and computerized health records. The Utah Population Database has been able to attract the large medical systems in Utah to share their electronic medical records in a very confidential way, and a cooperative population. As a brief outline to this population database, it includes the modern-day pioneers that arrived in the Utah Valley. This is a photograph of one of them, up to 15 generations, and statewide linked data, including births, deaths, marriages. The Utah Cancer Registry is there. All of the hospital discharge information, surgery, voter registration, and driver's license data. And as I've mentioned, indexing of the electronic medical records. There are about 9 million individuals in this database. The other program is the Health Family Tree. For a number of years, I have directed a program where we teach high school health and science teachers to work with their students to educate them about the interaction of genetics and lifestyle. A series of modules are provided to the teacher that they share with the students, and the student is asked to take home a large fold-out pedigree chart. My colleague is demonstrating one of these charts here. Each of these very small boxes that you can see on this chart, if I expand that, it includes information about the student, their parents, siblings, grandparents, and aunts and uncles. All of the health conditions of that individual and when that occurred is recorded, some of their lifestyle practices, but important for this topic, the usual body weight. And there are 5 categories, one of which asks if they consider themselves 100 pounds or more overweight. And if they're deceased, what was the cause of death and the year that occurred. All of these, the students are asked to record electronically so that they can be used for research purposes. Parents are also asked if they would like to have us contact them should we find their family to be at risk for, say, heart disease or a certain cancer type or obesity. Based upon the years of interaction with the high schools in Utah, we've collected about 150,000 families representing over 1.2 million individuals. And so it's from this resource that we're able to randomly select, in the case of our research in obesity, severe obese individuals. I've circled the number of at-risk people indicated by that 100 pounds or more overweight, about 400,000. From that database, years ago, we approached NIDDK to fund us to try and find genes related to human obesity, and particularly severe obesity. We used that health family tree database to identify over 5,000 families who had a high prevalence of severe obesity. In fact, from that, 1,400 of those families had 2 or more family members with severe obesity. We contacted 221 of the probands, severely obese probands, and then we began to expand their families. I have a picture here of a family reunion. We would go to family reunions, set up a couple of booths and drop blood, and people were very, very anxious to help us in this endeavor to try and find more about the cause of severe obesity because so many of their family members were affected. From that process, we have drawn DNA on about 6,000 family members from these 220 families. I'm just going to give you 2 examples. This is a busy slide, but this is one of the pedigrees. And this is it continues. I didn't have a large enough space to show it horizontally, but this is one pedigree. The solid black circle are women who are severely obese. The solid black square are men. That's appropriate. Men should be squares, I think. The half-filled circle or square represents 50 pounds or more overweight. And you can see the high prevalence of severe obesity in this pedigree. This is another example of one of our expanded pedigrees. Again, these individuals anxious to assist us, and we have collected DNA and other demographic data on these families. From these, we've taken the 72 largest expanded pedigrees, and I'm representing them here in this illustration to give you an idea of, again, the high prevalence of severe obesity that occurs in these families. On the far left, it's the number of severely obese affected persons. On the x-axis are the 72 pedigrees. And I've drawn a red line at 10. You can see that of those 72 pedigrees, on average, almost 10 severely obese families, with the greatest being almost 100 affected severely obese members. Our data has shown that severe obesity truly is a family affair. Families with severe obesity were 16 times more often to express that phenotype than in the general population. In fact, 48% of the severely obese probands had one or more severely obese first-degree relatives. And this is quite amazing given the fact that in the general population, severe obesity is probably 4 to 6%. 12% of the probands were actually 100 pounds or more overweight by age 20 to 24, and almost half of them were at least 50 pounds overweight by age 20 to 24. And if a child had a parent, one or both parents who were severely obese, their risk of being severely obese themselves was almost 3 times. We also wanted to look at the effect of pregnancy in these pedigrees. We did a sub-study with 96 severely obese women and compared them to 115 non-obese control women. The mean pregnancies was 4.3, with 1 to 9 being the range. And we regressed the weight of these women at age 46 on the total number of pregnancies, adjusting for their weight at age 20 to 24. The weight gain at the first pregnancy in the severely obese women was greater than 3 kilograms more than the controls. And in fact, looking at weight loss following pregnancy and then weight gain for the next pregnancy, it was significantly greater among the severely obese women. We also have identified some what we believe are important gene markers for severe obesity. This is an example of one predisposition locus for severe obesity. This is a LOD score graph, and looking at the codominant, dominant, and recessive models, all at the 4P15, P14 locus, the LOD score 10 and greater. The last couple of years, we have also been interested in looking at the other extreme, that is severe thinness. And from this database, both the Health Family Tree and the Utah Population Database, we are now recruiting families who have a high prevalence of thinness. We screen carefully these individuals, making sure they're not extreme exercisers, if that's a word, or with eating disorders. These are individuals who, when we ask this question, and we ask this question of all of them, can you eat anything you want and not gain weight? The answer is always yes. And we're looking at individuals with a BMI less than 18.5 as the proband, and we've now expanded to about 180 thin proband families, pedigrees, and we're now performing whole exome sequencing and on a subset full genome sequencing. Here are 2 pedigrees showing the thin families. In this case, the solid line is a BMI less than 19. Incidentally, for this family, you can't see the BMI because of the small print, but the next greatest BMI is 23 in this entire family. No one is greater than 23. Here is another expanded thin pedigree, same high prevalence of thinness. Using the Utah Population Database, we searched that resource and found 1.2 million individuals who had a genealogy of both parents, all 4 grandparents, and 6 of the 8 great-grandparents, and 600,000 of those being linked to driver's license data. From that, we found over 4,000 individuals from those pedigrees that had a BMI of less than 18.5. We did a statistical analysis called the GIF, and the results were that there was an excessive familiar clustering for low BMI phenotype. In fact, it was highly significant with a risk ratio of 2.21. So, end of that section. I'm convinced that with the patients you work with, that it's a family affair, that there is a very, very strong influence upon them becoming severely obese that is primarily a genetic influence. The next topic is that bariatric and metabolic surgery is the seed. I don't know if any of you, when you were in junior high or high school, did the sugar crystal experiment. Essentially, this is to boil some water and begin to add sugar, and you supersaturate the water with sugar. The fact that the water temperature is increased, it can take on more sugar, and then you let the solution cool by putting it in a glass jar, and you introduce an object, a thread, for example, or a piece of yarn, for example. In this case, I've referenced that as the seed. As the water temperature decreases, it's no longer able to hold the sugar molecule, and so the sugar seeks an object to form crystals. And so to me, and I'm so grateful for the work you have done in the past and are now doing to provide this seed for discovery. Bariatric and metabolic surgery as the seed, as you know, has advanced science in physiological mechanisms, inflammation, metabolism, biomolecular mechanisms, morbidity, mortality, quality of life, neoplastic changes, and cognitive disorders. Just a couple of days ago, I contacted a colleague, Maureen Rice at McMaster University. She did a quick PubMed search for me of all the bariatric surgery articles per year, starting in 1970 to current 2015. And you can see the exponential rise in the science that is coming forward because of this seed, bariatric and metabolic surgery. I'm going to just spend a few minutes and talk to you about how this seed has assisted our group in Utah, in cardiovascular genetics. One, as Dr. Morton mentioned, is in the area of mortality. It turns out that to date there are 29 published studies on mortality related to bariatric surgery. 15 of those are on cardiovascular cause mortality. Of course, the methods vary, and when severely obese controls are included as part of the study, without exception, all-cause mortality for the bariatric surgery group has been improved. Here is just a listing of those with control groups, and the percent reduction in mortality ranges from about 29%, the SOS study, to as high as 80%. Here is the other group, again, of severely obese mortality studies with controls. This study, just published a couple of weeks ago, is, I think, worth noting. The work by Eliason and his colleagues was to identify bariatric surgery patients who had diabetes prior to their surgery. So there are 6,000 patients with diabetes who then went on to have a gastric bypass, and they were matched very carefully with the same number of non-bariatric surgery severely obese controls who also had type 2 diabetes. In a rather short follow-up period, 3.5 years, they demonstrated a 42% reduction in mortality. In addition to this study by Eliason, another by Johnson, is rather unique in that these patients had pre-cardiovascular events prior to their surgery. So 309 bariatric patients who had cardiac events then went on to have bariatric surgery, matched to 903 non-bariatric but severely obese patients, and 40% reduction in mortality. The study that Dr. Morton mentioned that our group has published, it's somewhat dated, and so I'll just very briefly mention all-cause mortality, about 40% decrease. In reference to heart disease, 49% decrease, diabetes 92%, and cancer, which was a real surprise to us. And it was a surprise to everyone who assisted in the review of this paper that cancer would be significantly reduced. Gratefully, the SOS found the same thing. Their second largest number of deaths was cancer. In addition, the non-drug accidents, poisoning, and suicides, although not significant, did show a trend toward increased among the severely obese population. And if you do not have surgery, compared to if you do have surgery, in that first year following surgery, I thought this was a very telling statistic that the gastric bypass patients 1 year following their surgery of 42 deaths compared to the driver's license applicants that we compared them against 41 deaths. I've had a lot of people say, what about those driver's licenses used though? How accurate are those? People fudge on their license. And so I wanted to just mention, first of all, that in Utah, when we apply for a driver's license, we have to record our height and weight, and it is self-reported. Some states do not require that. By the way, I think that's an excellent picture there on my driver's license. Usually I look so ugly, but on this time it turned out pretty good. Using the permission from the driver's license division, which took 1.5 years to obtain, we manually, by hand, searched 1.6 million microfilm records. Took 1.5 years to extract 16,000 severely obese applicants, over 35 BMI. And then we electronically searched from 95 to 2002, 2.6 million. And this is what we did to make sure we dealt with the fudge factor. It turned out that 592 of the gastric bypass patients had applied for their driver's license a mean of 1.8 years before they had their surgery. So we had their self-reported BMI, height and weight, within 1.8 years before their surgery, and then we had their actual measured height and weight just a few days before their surgery. So we compared those two and developed a regression equation to correct for the fudge factor. More recently, we've looked at this original mortality data by age at surgery. And this is all-cause mortality of the New England information, again by 4 age categories. The gastric bypass are the solid color. And note that in all age groups except the less than 35, a significant lowering of mortality for the gastric bypass group. In fact, if you look at the non-gastric bypass group, you almost see an exponential rise in mortality as age increases. And if you compare that with the gastric bypass, it's quite flat, 35 to 54 years, and then just some increase, 55 to 74 years. The reason we believe the increase is greater in the less than 35 is with external cause mortality. You see that less than 35 is where we're having the greatest number of deaths or the impact of suicides accidents, those externally caused death. After 35, then again the gastric bypass group remains significantly lower in mortality. With terms of cancer, I think our group was the first to look at the incidence of cancer following bariatric surgery. And we used the Utah Cancer Registry to link with, again, the driver's license applicants. We looked at type of cancer, vital status, date of diagnosis. Long story short, there was a significant reduction in incidence of cancer. This is not mortality, but incidence, with about 32% in all cancers. Only females was significant, with a 27% reduction, and obesity-related, highly significant, 98% reduction. Finally, the study we have been doing for the last number of years, looking at 1,156 participants, a third of which have had gastric bypass surgery, a third of which were seeking gastric bypass, but their insurance would not cover it. And then from the Utah Health Family Tree Program controls, we're now out to 12th years, and we'll finish that 12-year follow-up by the end of the year, and we anticipate about a 90% follow-up, with about 80% of the surgery group that have returned to date. I just wanted to point out the weight compared to 6 years is no different at 12 years. So they have not gained any weight. This is the mean gain of weight from 6 to 12 years in the gastric bypass group. A study recently we conducted using the Utah Population Database to look at the impact of gastric bypass surgery on mothers who had pregnancies before their gastric bypass, or women who had pregnancies before and after surgery, both, or only after surgery, and they were compared to severely obese control women. It was a pretty tight match. Out of those 8,000 women, we were only able to accurately match 236 because of the strict matching criteria. We had to match with the same number of children, and the order of birth had to be the same before and after gastric bypass surgery with the control, and the birth year had to match. From that, we showed that those women who had had gastric bypass surgery were significantly less likely to have large gestational age children. However, they did have an increased, although not significant, in risk for small gestational aged births as well. Finally, coronary calcium, a study we've recently published, a subsection of participants in a 6-year visit. We've tested all the participants at 12 years, the coronary calcium, but we don't have those data. But if you look at the average coronary calcium score for the gastric bypass patients, it's 33 versus 107 in the controls. And as you look at both zero calcium score, 1 to 10, 11 to 100, and greater than 100, they're all significantly lower in the non-surgery group. I want to express appreciation to our cardiologist and Dr. Kolotkin, and to recognize there are many other studies that have been published in this regard. Finally, refining the crystals, the future. I've asked some of you as leaders in this wonderful organization what your thoughts are about one future opportunity for metabolic and bariatric surgery to significantly impact our population, the title of this talk. I'm going to just read these to you because I think it's worth thinking about this, and you young research people in the audience may want to take note of these for a possible R01 study. Dr. Dixon, bariatric metabolic surgery works primarily through brain regulatory centers, and therefore understanding the effective pathways will enhance benefits, reduce collateral risks, and lead to a range of safe and effective therapies. Dr. Corkelis to definitively answer the question, is bariatric surgery more effective than non-surgical care for the long-term treatment of type 2 diabetes in people with less severe obesity? She feels that is a critical opportunity in the future. Dr. Cummings, I suppose the single most important thing is to clarify the mechanisms by which bariatric metabolic surgery promotes weight and diabetes remission in the hopes of identifying new drug targets, but randomized trials with hard endpoints comparing surgical versus medical lifestyle approaches for type 2 diabetes would be in close second place. Dr. Wolf, the metabolic and bariatric surgery community has the opportunity to identify specific populations who will benefit from specific surgical interventions, thereby facilitating maximal population benefit of future health care resources, personalized medicine for the bariatric surgery patient. Dr. Rubino, metabolic surgery provide the best evidence, albeit not the only one, that the gastrointestinal tract is a key player in metabolic regulation, that diabetes is not invincible. These are the most consequential implications of metabolic surgery for the future of diabetes research. Dr. Kroll, reproductome study. He suggests an important opportunity as a comprehensive phenome, epigenome, and metabolome study of sperm donors and reproductive age women, pre and post conception and delivery, before and after highly standardized non-gastric intestinal diversion. I haven't talked to him about that. Dr. Pori's metabolic surgery at last offers the opportunity to define the molecular mechanisms that underlie type 2 diabetes and with that understanding develop the more effective medications to defeat this costly and cruel disease. Dr. Buchwald, because of the unremitting prejudice against the disease and the operative therapy of morbid obesity, it is important for the future of metabolic surgery to alter our emphasis to treating metabolic diseases such as type 2 diabetes rather than obesity per se. Dr. Blackstone suggests that epigenetic resetting of genes that govern metabolism is the key to understanding and correcting metabolism and has the potential to unlock a deeper understanding of much of the human disease, establishing a system of core where the signals of endothelial insulin resistance and inflammation are detected early and people are able to be cared for systematically before they become obese, should allow us to save lives even without a miracle drug, device, or procedure. Dr. Arterburn suggests that with the recent introduction of sleeve gastrectomy and the fact that it now comprises more than half of all bariatric procedures, our most pressing clinical and scientific questions are to understand how sleeve gastrectomy and gastric bypass compare on long-term 5 to 10-year weight loss, weight regain, diabetes control, cost of care, and rates of adverse outcomes. Dr. Cohen believes that the open avenues today in metabolic surgery are randomized clinical studies comparing surgery plus medical treatment and medical management alone. These have the long-term hard endpoints and as type 2 diabetes, microvascular complications, and CV events and mortality. This will be the legacy for our future patients. Dr. Phobie, this is interesting, suggests that the standard of care should be that morbidly obese patients get a bariatric surgical consultation. Dr. Schauer says, let's get NIH to lead a multi-center RCT comparing metabolic surgery to best treatment for diabetes with a BMI greater than 25, powered for hard clinical endpoints. He believes this would enormously advance the science and treatment of type 2 diabetes and benefit millions of people worldwide. Dr. Livingston suggests there are two things that need to be done in the future. One, the ability to predict which patients will be successful following the surgery, and the very long outcomes in terms of weight loss and comorbidity control. Dr. Kaplan, the therapeutic reach of bariatric surgery extends to metabolic, inflammatory, neoplastic, and cognitive disorders. Research to gain a full understanding of the physiological mechanisms stimulated by these operations will help to prevent and treat survival or several of the most important chronic debilitating disorders affecting people worldwide. I think just a few more. Dr. Sugarman suggests we need to have additional data on micro and macrovascular diseases such as renal failure, amputation, blindness, etc. Dr. Leroux believes we should have some randomized trials on mortality. Dr. Mitchell determine risk factors for and begin to develop prevention interventions for the development of adverse psychological outcomes following bariatric surgery, including drug and alcohol misuse, depression, and suicide. Dr. Gagne, I want to see mass surgical treatment of obesity and type 2 diabetes urgently from a worldwide number of 500,000 to 5 million patients a year. Otherwise, we are a drop in the ocean and have no impact on populations. And finally, Dr. Ponce, patient selection for the best obesity therapy based on at-risk benefit of the therapy and the patient's demographics and associated medical conditions, including genetic profile. I end with two final. Dr. Sostrom, one of the most important effects of bariatric surgery is to reduce the incidence of diabetes. And then our president, Dr. Morton, help us ensure that every individual in every state has access to bariatric surgery because our patients deserve a second chance for better health. I end with the concept of criminals always leave evidence. There's a belief in criminology that says no one can pass through a room without leaving some evidence. It may be a footprint, a fingerprint, fallen hair. Something has been changed by the person's presence. There are scores of people waiting for someone just like us to come along. People who will appreciate our compassion, our encouragement, who will need our unique talents, someone who will have a happier life merely because we took the time to share what we had. Too often we underestimate the power of a touch, a smile, a kind word, a listening ear, an honest compliment, or the smallest act of caring, all of which have the potential to turn a life around. You as surgeons have left a great deal of evidence in the lives you have affected by your patients. Dr. Mason, being the father of bariatric surgery, has left a great deal of evidence, not only for you professionally, but for the patients and family members that have been affected by his years of great service. I want to acknowledge the evidence left in my behalf by NIH, their funding over the years for the bariatric surgery research, Dr. Yanofsky, Dr. Hubbard, Miles, Dr. Karp, Dr. Evans. I want to thank the three bariatric surgeons that have allowed us to take their data with no questions asked in terms of trying to sway us one way or another, Dr. McKinley, Dr. Smith, and Dr. Simper. And I want to mention with sadness in my heart the passing just a few weeks ago of Dr. Smith. He did all he could, knowing he had perhaps terminal cancer, to make it to Vienna to give a talk on gastric bypass surgery. This is his family. I want to thank all the colleagues that have assisted me and have touched my lives, leaving evidence for me to work through and to hopefully improve upon, to answer these important questions. I point out in particular Dr. Davidson and Dr. Hunt, and my family that have supported me in my professional endeavors. They have been a great support. Finally, and most importantly, I suspect, are the grateful patients that have been part of the studies that we have conducted. Each of these two patients asked that I share these photos. I didn't ask them for it. The gentleman on the right, he came in after 2 years following his surgery and handed me this in the clinical research center. I meet with them every morning when they are tested and spend the night there. I remember him coming in prior to his surgery for his baseline testing, and he had to stop every 15 or 20 paces or feet to catch his breath. When he came in at 2 years for his test, he handed me this picture and said he had just climb down and up the Grand Canyon. These patients have provided a great deal of opportunity for our research group, and we appreciate them. And I know they appreciate you as surgeons, and I know you have a great impact and evidence that you leave in their lives, and that they hopefully are able to extend to their family by being healthier and happier and more able to contribute to the society as well as to their family. If any of you would like a copy of this presentation, you can email me. I say that because reading all of those comments was rather lengthy. I apologize if it was too lengthy, but I think it was key to hear from you about what it is that we can do to impact the future of our population through bariatric surgery. Thank you.